Yes, children, previously we discussed about de Broglie wave equation, right? So let us discuss one more equation, that is one more principle we having Heisenberg uncertainty principle. So what is that? Heisenberg uncertainty principle. Heisenberg uncertainty principle. Heisenberg uncertainty principle we are having over there, right? What is mean by Heisenberg uncertainty principle means, so simple thing that in the name itself having, right? Who is that fellow? Heisenberg is there. What is said? Uncertainty. What is mean by uncertainty? Generally, we'll say that certain things we'll say no. Certain means a particular. Uncertain means not particular. They are not particular, right? So Heisenberg uncertainty principle means, so just now we discussed about whatever the materials are there, matter is there, right? Particles are there, they have the wave nature, right? And from that we derive the momentum also, no? So lambda is equal to h by mv, that is mv means momentum we call it as, so velocity we discussing over there, and the position also we are discussing over there, right? So here Heisenberg said that it is impossible. It is impossible. We should write like that only. We should write like that only, right? So it is impossible to find the position. It is impossible to find the position and momentum, or else you can say it as velocity also. No problem, right? So it is impossible to find the position and momentum simultaneously. The word you need to write compulsory is that it is impossible to find the position and momentum of a particle simultaneously. Did you get it? Right. So let me explain. We'll take example like what, fan will be there, right? Fan, right? So for the fan, what were there? So three hands will be there, no? Right? A fan is there, suppose. For the fan what will be there? Three hands will be there, no? So that will rotate, no? It revolves like this, no? Right? So if you assume that each hand is a particle, it is revolving, around itself, right? So what happens then? Now suppose here this is the first hand is there, second hand, and this is the third hand. Three hands are there, right? Now can you tell, when we switch on the fan, can you say the first fan, where is the first fan while it is rotating, while it is revolving? Can you say the position of this first hand? Can you? No, right? So that means what? You cannot identify the position when it is in a velocity. It is having certain velocity, it is revolving with certain velocity. You are not able to identify the position, right? Okay, now let us find where the position is there. That means I need to do what? I need to switch off the fan, then fan will comes to rest position, then I can easily able to identify the position of the hand, right? So that means what? That is, we are able to find the position when the momentum is become zero. That means no momentum is there, but our condition is what? The particle should be there, that is in a momentum only, that is with the velocity only. They always revolves, already we discussed, the particles always revolves, whether they are taking the energy and they are revolving. After using that, they emit energy and they are coming back, right? So either they are going to energy levels or they coming back, right? Even in the both ways, they are moving only, they are not stable, right? So that means what? The particles will not be stable. The particles should not be stable. That means what? Momentum should not be zero. But when you are finding the position, we are finding it when the momentum becomes zero. But that should not be happen. That means what? It is impossible to find the position and momentum of a particle simultaneously. Just you assume the fan structure whenever, right? So that means what? So it is impossible to identify the position and momentum simultaneously, right? So did you get it? So let me tell you again. Suppose a fan is there, simple thing, right? Fan is there, when it is in a momentum, that is when it is revolving, we cannot identify the position of the particular hand, right? So that means you are not able to find the position. That means it is having a particular velocity. But if you are able to find the position, means the velocity must be 0. When it is become 0, then you can able to find this. But that thing should not be happen, right? So for that, he has given one equation. That is, Heisenberg has given one equation. So that is delta x into delta p is greater than or equals to h by 4 pi, right? So here p, delta p means momentum, delta p means momentum, delta x means position. So x means position, right? So x means position, p means momentum, then what is delta? Delta means uncertainty. That means we are unable to find it, no? So that unable nature is nothing but uncertainty, not exact. You cannot say exact velocity. Like you should not say, you are unable to say the position, right? So that is uncertainty. Uncertainty means not exact, right? So that is what, and h means Planck's constant, we know 4 pi is a constant value, right? So he said that what, the product of uncertainty of momentum and position, that should not be lesser than the h by 4 pi. A value is given and the product should not be lesser than this. They must equal or more than h by 4 pi, right? So that means, suppose here delta x and delta p is there. Now if I want to find the delta x, right? Suppose you let it take it as, so delta x into delta p is equals to, you take h by 4 pi, suppose you will take. Now I want to find this delta x, I want to find. Now this should be, if it should be 1, if the delta p value it becomes 1, then the total value should be, because the value is of what, delta x only, no? That means it neither 1, that means it's neither less than 1, that means it neither be 0. That means now when you got the 0, when you find the velocity momentum 0, you got the position, no? That means when we find that, when it is 0 we find, but here if it is 0, then delta x also be 0, no? That is delta x into 0, that 0 into something is 0 only, right? So that is, it should not be like 0, it should be minimum value at least, right? So that is for the uncertainty. Heisenberg has given one equation, that is what, delta x into delta p is greater than or equals to h by 4 pi, or else that you can write like, that formula you also can write like delta x into delta p, right? So in the place of delta p I am writing m into delta v greater than or equals to h by 4 pi. Why? Because mv is equals to p. So delta p is there, so we are writing m into delta v. Why? Because mass we cannot change, we can change the speed of the object, right? Suppose if this marker is there, it is going with the speed, that means we can increase the speed or we can decrease the speed, but you cannot increase or decrease the weight of this marker, right? So that is the thing, mass should be same, mass cannot change, velocity can be changed, right? So that we can write like, so delta x into delta v is greater than or equals to h by 4 pi. That means it should not be 0, simple thing, first thing. Second thing is that you cannot identify the position and velocity and momentum, position and momentum of a particle simultaneously.